Go. Hi, I'm Logan McDougall, and we are ECE 4534 Group 9. Our project requirement was to use the capacitive touch sensors to control the train set. So the way capacitive touch sensors work is they are charged by a current source, and then the analog to digital converter on the PIC reads out the voltage of them. So you set them up to do that periodically, and then when the person puts their finger up against the glass like so, as you can see from this diagram here, there is a capacitance added in series with the original capacitance of the sensor. And then when the PIC reads out the voltage, it will get a lower value, and that will detect a touch. So that's the premise of our project. We're using it to control the train sets, which you can see in here. There's a train track. It has a couple of switches and some trains on it. And so we're going to use the sensors here on the window to control this train set.
Go ahead.
So we also need a way to display what's going on with the system. So we have this LCD hooked up here. All of our components are going to communicate over this cable here, which is using the I2C communication protocol. And this LCD that we chose is also powered by 5 volts, so it runs directly off the bus and communicates over I2C to make things easy. So on this screen you'll be able to see the state of the switches and the trains, and then it'll respond to your input over the buttons. Don't forget to introduce yourself.
Alright, ready? Yep. Alright. Hi, my name is Bradley Hockman, and we're also going to talk about a couple more requirements of our project. Our Spartan board is master of the whole system. It receives messages and sends messages out to the local net and LCD. We're buffering it with this V5 board because this has no I2C connection. So we buffer it with this V5 board so we can send out I2C messages to the local net PIC with the local net controller, and across this ribbon cable all the way over here to the capacitive touch sensor board and the LCD board. So this is what we originally thought our design requirements would be to get the trains running and the capacitive sensors to work.
So you might be wondering what some of these technology terms that we've been using, such as I2C and LocoNet, are. So I'm going to take a moment to explain this to you. The I2C stands for Inter-Integrated Circuit. It's a standardized protocol used for communication between chips on boards. In this case, we're actually using it to communicate between different boards entirely. We're running the I2C over this ribbon cable, which extends from here between these boards, all the way up here, across the ceiling, and all the way over to these other boards. And they're all using this I2C cable that we're using here also carries power and ground and supplies power to every board here. This LocoNet is a protocol that's used to communicate with the DCS50 over here. This DCS50 is the controller for this entire track. It's a peripheral that was provided to us by the manufacturer of this track. So this board here, the LocoNet board, performs the translation of the messages in I2C format and then sends them over this cable to your DCS50 in LocoNet format.
Hi, I'm Jonathan Doman. I was in charge of the Spartan code, and on the external interface, also in charge of the LCD. So we purchased an LCD here that talks directly on the I2C bus to make communication a lot simpler. The LCD has 4 lines, each 20 characters long, and it also supports up to 8 custom characters at a time. So it's actually displaying some custom characters on here right now. There's little left and right chevrons. So those were drawn and loaded up in the code. So the Spartan board will send the LCD commands or ASCII text to display, and it shows the current state of the whole system here.
So we've got a variety of different modes that are displayed on the LCD here. You can see right now we're in train mode. We're controlling train number 1, and as you can see with the nice custom characters, when you push the buttons, then the chevrons light up to indicate the speed of the train. And we have a variety of modes, so we can control train 1, train 2, and there's switch 1, and you can see you can throw or close the switch. Switch 2, same deal. Then we have a help mode, which displays how you control the train and all of the things that you can do with the system. And then there's a demo mode, which allows you to run the trains automatically. And you can see that the trains are going around now once we activate demo mode. So the whole system's controlled by these capacitive touch sensors here. And as you can see, when you put your finger on them, the button lights up. We've got a left and right button, which are used for a variety of different modes. And then there's the mode button, which allows you to switch between the modes. So the sensors work, like I said, using the capacitive technology. So they have a baseline capacitance value, and when you put your finger up against the glass, that changes the capacitance of it and gives you a different voltage when you read it out. So in order to get it to work through the glass, we designed the sensors to have a ground plane around them, kind of like this, with the sensor in the center of it, and they're also electrically isolated on the backside using a light cross-hatching pattern to keep out any interference to make them more sensitive. Because we are sensing at a distance from the sensors, the software to run it has to be very finely tuned in order to make them work. But once we successfully tune the software, everything works pretty well, as you can see. And our system does have one more mode, which isn't showing right now, but that's emergency stop. So if you set all of the trains to full speed, then you can just go ahead and stop them. You just put your hand over all four, and that just stops the trains.
Okay, so right now we would like to talk about the trains and how we got them to start moving and how we communicated to the train to ECE 50, the local net, which controls the trains. Right here we have the Spartan V4 board connected with the local net PIC, which is simply just a buffer PIC with a telephone wire cord coming out to hook into the ECE 50. This receives the I2C messages and will retransmit them to local net commands, which is the commands that are used for the train. And you can see loadings on the outside operating trains, and it is now receiving messages. As you can know, this red light's on and the trains are moving. We got it set up so it's a standardized 2-train setup with, you can control 2 trains and you can control 2 switches, switch 1, switch 2. You are also able to crash the trains into each other if you need, so you have to be careful because there's no code that checks to make sure they run into each other. Another thing we did was that we keep sending the speed of the train if nothing's being pressed to keep the trains going on a timer interrupt on the local net board.
So I'm going to give you a short overview of the track layout that we're using to run these trains on. So the track is circular. It has an inner track and an outer track, as you can see here. There's a variety of switches here in the middle that are used for the turnouts. There's that one and that one allow you to get to the center of the track. We have those switches disabled for the purposes of this demo so that people don't run the trains off the track into these end pieces here. So we're actually only using this switch, that one, that's switch 1, and this is switch 2 here, which allows you to get between the inner and the outer track. And then there's 2 trains on the track. There's train 1 and train 2, which can run on either loop depending on the positions of those switches.
Okay, so the Spartan 3E board here is the master of the entire system. It controls basically everything that's going on. So every 100 milliseconds, about 10 times a second, it'll ask the touch sensors for some data, and the touch sensors will reply with whether or not a button has been pressed, or which buttons are currently being pressed. So then the Spartan board will decide what the buttons mean and what to do with that data. So it will either send out a command to the LocoNet PIC, or it will send a command to the LCD to update the display. to design the system for robustness, I have the Spartan board configured to check after every I2C message whether the slave responded and whether it properly received or sent data. So it is polling the sensors about every 100 milliseconds for data, and it checks to make sure that the sensors are responding. So if the sensors don't respond, then it will stop the trains and put a message on the LCD saying that the system is not working. So here we see the sensors being disconnected, and it shows sensor disconnected. And when they're plugged back in, it should automatically reset the system.
Okay, in conclusion, we successfully met all of our design requirements and project goals that we set out to successfully accomplish our project. And we've got 2 trains moving, and you can throw switches to change them up. You can just put them in demo mode, and they just shorted out because they just connected. And e-stop.
They crashed into each other.
So,
We don't have any error protection to prevent people from crashing the trains, unfortunately. That was a goal that we had added initially, but we didn't have time to complete it.
that would have been a whole other project.
Yeah, it would have been more like an extra credit.
Special thanks.
Oh, and also, we'd like to give special thanks to Bob Library for helping us out with the board designs and procuring all the parts for us. He really made this project possible.